Hey folks, this is Costa Banerjee and this is a task 2 which was assigned to me by the Sparks Foundation, and this task is about to explore an unsupervised machine learning problem. So the description is from the given iris dataset, predict the optimum number of clusters and represent it visually. So this is the dataset, as you can see, and by the way I'm using Jupyter Lab, so that's why I can show you like this. So first I'm importing the libraries, then loading the dataset. So this is the dataset, then dropping the ID because we don't need that, we already have one like 145, 146. We are dropping this ID. Now we are displaying the first 5 rows with head and the shape, that means how many rows and how many columns are there in this dataset. Then this is the information of the dataset. So what's the data type of simple length of all the features, what's the data type of all this, and how many non-null characters are there or non-null datas are there. We can show this by this information function. So now we are describing the dataset, like count, mean and all. Now we are dropping the null values, we don't need that. We are dropping the duplicates also. Now we are doing the label encoding in here. So again I'm showing the dataset after this label encoding. Now this is petal length versus petal width, okay, in centimeter. So we will use this to compare with our predicted dataset at the last. This is a correlation matrix among petal length and among all the dataset. This is a correlation matrix. So now we come to the exploratory data analysis, and so we have already plotted a correlation matrix, and this is the plot. Okay, so this is a heat map, and white means the more we go to top, it means it's highly correlated, means two features are correlated among each other, and if it's dark then two features are not at all related. So we can observe from the plot that the species is highly correlated with the petal length and petal width. So as you can see, 0.95, 0.96. So we are dropping the species because it's not needed, and we are converting the species to numpy array. Okay, so now we are modeling. So we are using k-means clustering, and I'm using this elbow method, that is within cluster sum of squares. So I plotted the graph and it looks like this elbow. So you can see I have selected this 3 because as you can see that increase in cluster equals to decrease in this value in WCSS value, and WCSS means this is within cluster sum of squares. So the optimum, as you can see the angle, so we can see that after this 3 the angle is quite linear, so that's why we are using this 3. So now using the k-means clustering, we are predicting. So here is the prediction, and now finally we are visualizing the clusters. So here you can see, and these stars are the centroids. Before we have already plotted a plot like this, a scatter plot like this, and I said that we will be comparing. So this value and that value are kind of same, so we think that our graph is quite good. So thank you, and feedbacks are always welcome. Thanks again.